Hi, today I want to talk about errors in programming and Java in particular. And then the Java language is a big fan of this particular mechanism called exceptions that allow us to manage errors in a formal way, in a safe way. So let's talk about this. So for this video, we want to review some different types of errors we might encounter in code or in running a program. To learn about Java's exception mechanism and to see how to structure code to manage errors. And these are all important as we start building more complex projects. A couple quotes for you. If debugging is the process of removing software bugs, then programming must be the process of putting them in. And that's a quote from Dijkstra, who's a very famous computer scientist. And I think it's a quote that resonates hopefully with all of us. As we write code, it's often frustrating that things don't work. And again, it's our responsibility to realize that we are the ones writing the code that makes it not work, and we need to fix it. And then another quote: the first 90% of code accounts for the first 90% of development time. The remaining 10% of the code accounts for the other 90% of development time. And of course, that adds up to 180%. But it's basically saying that it's kind of easy to get maybe the framework of your code out there, the rough structure. And then it's that last bit, getting it all the work that just takes even more than 90%, probably, well, it takes all the time basically. And so one thing you can do as you write code is to, one, try to do a good job writing it in the first place so you're not tracking down errors later. And to, as you write it, make sure you sort of are trying to create a program that runs all the time and can give you some sort of output. And so you can always test what little addition you've just made. All those things you'll sort of gain skills in making sure your project sort of stays on track as you get more practice writing code. So again, in an intro programming course, a lot of the errors are syntax errors, and they are errors that are found at compile time, or really, in Eclipse, it basically is checking those kinds of errors continuously for you, and it'll try to do like red squiggles and stuff like that to tell you something's wrong. One example of this is, here's a little method. It doesn't really do anything except return a 1, and it's an int return type. And here we call the method in main, a different place we call it, and we're assigning the result of this to a string, and there's a type mismatch here, right? We can't assign an int to a string, and that will cause a compile time error. Basically, the compiler can check and say, hey, I know that this value has to be of this type, an int, and I'm trying to assign it to this thing that doesn't know how to get assigned an int, and that just can't work. We can't even run the program, right? And again, it is important to look at these errors carefully and try to make sure you understand what it's trying to tell you so you can fix it. Then logic errors happen when the program compiles and runs, but the solution has a flaw. Here is a little sample code factorial. Some you might be familiar with a factorial function, 5 times 4 times 3 times 2 times 1. That shows up in mathematics. And so we have a loop here, and it is weird how my cursor just doesn't want to show. We have a loop here, and we're going to count up to n and multiply that 1, 2, 3, 4 times this thing that's accumulating the answer. Now the error here is that we're starting off at 0, so 0 times any number is going to be 0, and then when count is 2, 0 times 2 is 0. We really need to start at 1. And again, how do you find that kind of error? Well, when you test it and you realize that, hey, I said factorial of 100 and I got 0 instead. And then how do you track it down? You start printing stuff out. Like here, you do a system print line and say, what is factorial? What is count? And you realize it's 0 and 0 and 0 and 0. And then eventually that leads you to an insight that you need to fix this line here. But it's really through this painstaking investigation that you fix that kind of stuff. Now, an error that some of you have run into, but it's a little different from that, is a runtime error. And that is basically you're running your code, and the program basically has an exception. It crashes. It stops running. And those are things that are illegal operations that you try to do in your program. So, for example, you could try to divide by 0, and you're not allowed to divide a number by 0, and that's going to cause an error. And maybe this is the result of some computation, and so you don't know, it's not like you typed 4 divided by 0, but it's like 4 divided by count or something like that. and you need to figure out what went wrong. There, you maybe have a string with 2 characters, and at some point you ask for character at index 2, which sort of sounds good because there's 2 characters, but of course 0, 1, 2 is out of bounds. And again, that causes some kind of error. And again, maybe that's sort of fundamentally a logic error, like why are you trying to get that second value anyway, but it shows up not as a wrong answer, but as a crash of the program. Another thing you can maybe imagine is something like trying to open a file that doesn't exist. You give it a name and say, open this thing, and then it's not there for it to open. And so what does it do? It has to crash, basically. And I think the key here is that it's not really things that can be caught in advance. In other words, you don't know you're going to try to ask for that second character. It's very hard to write enough logic in your code to sort of prevent that all the time. So Java uses a mechanism called exceptions to respond to runtime errors, and it's a very powerful technique. It's deep into Java's DNA in some sense. Java, I think, uses exceptions more than many other languages, and you're going to see a lot of this exception stuff as you code, and both in working with other code and then code you write yourself. And I think they're fairly complicated statements to write. Like they're big and they have a lot of parts, and they just sort of they take a while to learn how to interpret properly. But it's very important for you to start seeing how these work. Certainly in CS2420, you're going to use these a lot. So here's the basic model. You have a cursor, come on, it's weird. You wrap some code in a code block, so curly braces, and use the try reserved keyword. And then if some exception happens in here, one of these runtime errors, those errors do what's called throw an exception, and your code's job is to catch the exception. In other words, it sort of stops doing what it does here, jumps down here, and then there's some code to respond to the exception here, right? So there's sort of this what's called a try block, and then there's a catch or multiple catches that somehow try to not necessarily fix the error, but at least make the program not crash. And maybe try some default value, try some code again, that kind of stuff. So it's this big statement, though, that goes over multiple lines, and that's what kind of makes it a little bit complicated. Okay, so in some ways, I like to think of this catch as, it's not really a standalone method, but it sort of looks like one, right? It has a little block here, and any code that throws an exception is basically throwing an object, an exception object, that is assigned to this variable here. This is just like a parameter of a method. E is not fixed. You can call it anything you want, but there's sort of a, it's not a very meaningful variable name for sure, but it's sort of a slightly standard one, and it's sort of okay in this context to have something like that. Oops, what am I doing here? Hold on a second. Okay. So let's try an example here. Let's write some code. It's really bizarre how my cursor is just kind of going away. All right. So I'm going to have a string I make, and it's just going to be hi, a little friendly something, and let's see an exception first. Let's cause an error. So I'm going to try to grab a character past the end of the string. So we can kind of force that to happen, right, using the char at, and I'm going to get it at index 2. So if I were to run this, again, you get sort of, again, these are sort of intimidating, right? Exception, that means error, in main, and it's telling you where it happened. Well, first of all, it's telling you string index out of bounds exception, string index out of range 2. So it's telling you, here's the thing it tried to use, 2, and that's out of range. In other words, too big. If it was a negative number, it'd be too small. And it happened here at this line in class lecture 15 line 7. And of course, that's where we see it here, right? And you can even click on that, and it takes you to the line. So a lot of nice tools to help you figure these things out. This stuff is because it actually went into the string characterette method and tried to extract that thing, and the error really happened down deep in this method here, right? So this method, this line called it, but it really happened down in this method here, and it got this exception. All right, so we want to somehow manage this error. So I'm going to use a try block, and in the try is where I am going to try out some code that may cause an error. It doesn't have to cause an error. In fact, you don't want it to cause an error. But I'm going to try this out, and then, maybe after I wanted to use that that character, so I'm just going to print out what I think I'm extracting from the string here. And okay, that seems fine. And again, if I the form of this try catch is you have a block that you try, and if any error happens in that block, we try to catch it, and you say what you're trying to catch. So the most basic thing you can catch is a sort of generic exception, and when I catch an error, I'm going to maybe say something, I don't know. In some ways, you can't always fix the error, right? Sometimes you just have to kind of be graceful about dying or trying again. I'll just say error here. And then instead of, I'm going to just ask the program to quit system exit 0. And again, it's not that important to know exactly what that does. You can kind of return a status here as a number, but this is fine. It basically says stop the program. So if I run it again, I just get an error. It says the program is terminated, so it's stopped, and it didn't crash, right? I mean, it's always preferable to not, if you have some application, not dump out error messages to whoever's running it, and instead just, say something and die is okay. It's not perfect, but it's better than crashing. So as a mechanism here, we tried this line here. This line threw an exception. As soon as that exception is thrown, it looks for this catch block, and it says, okay, we were trying to handle an exception here, and run whatever code is in the catch block here. Notice it didn't print out anything here. So as soon as the exception is thrown, it jumps over any remaining lines in the try block and does this. Once the catch block is over, it will continue on running the program, except in this case, we told the program to die. So I can actually, let's comment that out. And here, I am going to just sort of indicate that, more stuff is happening. More program is running. So again, maybe move on to some other topic. So if I run it now, it says error. So what's the logic here? We come down, we try to get the character, it fails, it throws an exception. That exception is caught here, and it prints out error. It finishes the catch block. It doesn't go back up here and keep trying to do anything, and then it just goes on to whatever the next statement is in your program, and it says more program is running. All right, so you can see this is again, a fairly complicated construct, and there's a lot of parts to get right. Now I will say here, I might be aware that I'm worried about my string index being out of bounds, and there are specific types of exceptions out of bounds that are long, and you just sort of have to get, either look them up, try to Googling, see what exception is thrown in the first place, and try to catch that. This one will only catch a string index out of bounds exception that's thrown. If I tried to divide by 0 in this try block right now, it wouldn't catch it. It would actually just show that exception on the screen down here, right? So here I want to just be very careful about what I think I'm able to handle. Like, okay, if I do a string index out of bounds, let's make sure I'm only going to accept that type of exception, and then do something specific for that particular kind of error, and then move on. But I'm not going to just sort of try to catch everything. I will say that this try block here is its own scope. It's curly braces. It's a code block like any other. So for example, this character here only has scope inside these curly braces. And if I tried to use it down here, for example, it wouldn't work. Now, that I think is perfectly logical. It behaves exactly like we've seen other code blocks, but I will say sometimes you write code and then realize you have an exception issue, and so you wrap it in a try catch block, and you've basically pushed the scope of this thing down one level, and you can no longer use it here. So sometimes you have to declare the character out of the block, and maybe initialize it to some default value, and then set it down here and use it after the try catch. So as you code, it's going to cause some complications. You have to sometimes rethink how you're setting certain kinds of things up. You can have multiple catches. So they're kind of like one of those else-if chains in some ways. And typically you go from more specific to less specific, or more general. And I'm going to say general error. Okay, so if I run this program, it's still going to say error because this threw an index out of bounds exception. And so this caught it. It only goes to one catch block, and then it jumps on and continues on here. Let's see, I haven't really tried this. Can I just force some kind of... It may not even let me... I don't know what it's going to do here. It doesn't... That's funny. I thought I could just sort of have a little raw expression here. Well, let's try... Okay, just sort of... Let's try to compute some sort of index to use here. Okay, so what happened here? We want to get the character at some index. We evaluate this expression here. This expression is a divide by 0 error, and that is not a string index out of bounds exception, so it doesn't catch it here, but it catches here at this general exception. In fact, there is a, what is it called, a message? Let me just remind myself of what that, you can sort of see what the exception is. It's contained in that little variable there, get message. I was a little too brief there. So this says what the exception was. General error, I needed a space there. Run it again. Oops, don't do that. Debug. General error, divide by 0 is the error. So it tells you what it was, right? And then it moves on to this more programmers running. All right, so now we have this very awkward and ugly chunk of code. And notice this really does in some ways strain your comprehension of what's going on in the code, because there's so much stuff and a lot of long, weird looking stuff here. But it's still a very powerful technique. Now, here's the thing. Some of you are going to really say, hey, this is great. I can make my program be safe from all sorts of problems by just using exceptions. And don't do that. Exceptions are for exceptional errors, for things you cannot control. So here's some code that I see more often than I want to. Try in here a while true, and I'm just sort of, this is basically an infinite loop, right? And there's other ways you could set that up. But this is just sort of an example, right? And here I'm trying to grab some character at an index, and I add one to the index. So this thing repeats forever, and as soon as that index gets too high, it throws an exception, and I catch the exception. And then I move on. The right way to do this is to have some logic here that says when we should stop the while loop, when the index is too large, right? When we get past the end of the string. That shows the intent of what this code is supposed to do. And in this case, it just basically has a weird intent, go forever, and then, hey, here's a way to clean things up. first of all, this try catch mechanism is very slow compared to just like checking a conditional. It does a whole bunch of stuff to the system. Secondly, it really hides what's going on. It's an ugly construct. This is very bad. Like anyone who sees this, who knows anything about programming, will be very upset that you're sort of abusing this exception mechanism like this. So don't be lazy and use an exception. Use it to safeguard your code against unforeseeable errors, but not ones that are staring you in the face and you know how to fix. Now, let's make a little method out of this. Public static. I'm going to return a character, and I'm going to call it getChar, and I'm going to pass in a string, and I'm always going to get the second character, let's say, right? So here I have my example. I'm going to call getChar and pass in example. So the goal is I'm going to call this method and use it to get a character. And really all my main job in here is I want to get the character from the text parameter and return it. And I could return that directly, right? There's no, but I'm just gonna, I don't need this variable, this passed in variable here to make this code clear. And we're going to print out result. Okay, and let me just kind of comment this out for a minute. A lot of stuff going on here. Okay. So make a string hi, pass it in. So text is assigned hi. I try to get the second character and I try to return it. So of course when I run that, I get an exception, right? All right, so we can fix that exception. We know how to fix that. I'm going to do a try. And then I need a catch. Let me just grab this specific catch here. Well, let's just get that. And we need a catch. Okay, so we try to get the character. We print out an error if there's some sort of error. And then of course, okay, we have this issue now. This is what I'm talking about. Here's this. Well, actually, sorry. I got my indenting off here. Okay. Try block, catch block. We want to return something at the end. So passed end is defined in here. Its scope is this block. I can't use it down here. So one possibility is, well, okay, let's return it when I get it. Now it's complaining up here that I must return a result. I return it here, but if I throw an exception, I don't return anything, right? So I need to return something if an error happened. And the question is, what should I return, right? Maybe there's some, maybe there's some special character, I don't know, that I can return to show that an error happened. But of course, that has to guarantee that the question mark doesn't exist in this text to begin with. And then at that point, I need to do something down here to see if like a question mark was returned out of the method and maybe do some different result as well. So it's, in some ways, I'm using this try catch mechanism to stop myself from having an error, but now I'm using this other mechanism where I need to return a special case value out of here and then manage that special case value down here anyway. So this exception hasn't really done anything for me. It just stops it from crashing, but it doesn't, like this method doesn't know how to fix the problem. It's really this guy down here that caused the problem by sending in this too small a string, and it's its job down here to fix it. So there's this question of where we should handle the error. And in some ways, sometimes handling the error right away is the wrong answer. And so there's a throws keyword we can use to say that a method is expected or has the potential to throw an error, an exception, and it's the calling code's responsibility to handle it. So I'm going to add a throws string index out of bounds exception. So this is basically saying, hey, this method can throw an exception. When I do that, I actually get rid of all the sort of error management stuff here. And now, well, hold on a second. Did I do this wrong? Public static char get char. String text throws string index out of bounds exception. Well, okay, and it's, I thought it was going to warn me about this, but it's now this code's job to do the try catch. In other words, we're acknowledging that a problem can happen here, and it's our job to manage it down here. So I can catch that string index out of bounds exception. Is that the wrong name? Hold on a second. We'll see if okay, it's happy enough. And I'm going to say an error happened. Let me just get rid of all this stuff. Okay, so this doesn't maybe seem that different, but when I run it, let's see if it runs. Okay, there was an error, and then more programs running. What I'm trying to say is, okay, we know an error can happen here. If I don't have this, then the error that happens here will crash the program. By saying this, I'm saying I acknowledge that an exception can happen here, but I am not ready to manage that error. I'm not ready to fix it because I don't really know what the intent was of the person calling this method, right? So when I throw it, that means down here is where I need to do the try catch. So this method here, we know throws this potential exception, and our job is to manage that error if something bad happened. All right, so you can't just like fix it always in place and then just push the error, say, well, let's just return a weird result or something like that. You want to think about whose job is it really to fix this stuff. And in this case, it is the calling code in main. It knew why it called that method, and it knows how to fix it. Well, in this case, it knows how to say something about it. So you'll see this pattern a lot. This throws, it makes this method declaration look really long and awkward, and it sort of is horrible, to be honest. But it's basically a flag that we're going to use to say, hey, something else has to happen down here. Okay, so I think, let me just make sure that was what I wanted to end with on that. Yeah, so we'll keep using these exceptions and things, but again, they're complicated constructs. It takes a while to get used to them. The flow of control as the program runs now can jump in weird ways that we're not used to. It jumps from here down to here and sort of bypasses stuff, and we're used to things being a little more orderly, and I think that's confusing as well. But again, it's a mechanism that is used a lot in Java.